So today the lesson's called Linear Relations from Words. We are starting with words, but we're just going to do a whole bunch of different things. And really a lot of the lessons from now on are just different kinds of things that we can do, starting with one of the four representations. And in this case, it's very EQAO kind of questions. Again, you'll see that we've even called it an open response, so showing our work matters. Yesterday we talked about direct variation and partial variation, so whether or not it starts at zero and how important that is. In fact, if you go way back to the beginning of this unit when we talked about rates um, and something changing, is we saw that if it starts at zero, finding the rate is easier. Now, if you don't remember that, don't worry about it. But we did also notice that there's another reason why it's important to have a distinction between direct variation and partial variation. Okay, I'm not sure that's going to come up explicitly in this question where it's going to ask us if it's direct or partial, but there, as you know, there are going to be questions like that along the way, and it might just also be something we think about if we're doing graphs or sketches or that kind of thing. Does it start at zero or not? Okay, and coming up with the equation, it looks a little bit different, all of that stuff. Let's take a look at what this question is like. This is about a baby tiger. So a baby tiger is born at African Lion Safari. It is discovered that the tiger gains 4 kilograms per month. So again, we can assume that when it's born, it doesn't weigh zero. So it's probably not starting at number of months since birth, 0 kilograms. One thing I'll say about that though is just because it doesn't make sense in real life doesn't mean the question won't have that. And I know that seems strange, but you'll have to believe me that sometimes it sort of makes sense to have it that way. So don't use your intuition to say for zero, it doesn't make sense for, like, when a tiger is born, it has a mass, so it can't be direct and it can't have zero mass when it's born. You're right, that's true, but it's possible that a question will come up where it doesn't sensibly match the real world. Okay, so you got to look at the math, is what I'm trying to say. You have to look at the math. A really good example of that, if I can just for a minute talk about something else. In fact, I'm going to come right off the page and talk about that. Is let's say a cost of a plumber. Okay, and if I do the equation, then it's the cost equals, let's say, $100 to start plus $50 per hour. Okay, and so if I have the number of hours and the total cost, so for 0 hours, it would cost $100. For 1 hour, it would be $150. For 2 hours, it'd be $200, and so on. Right there, that doesn't make any sense. You're not going to pay a plumber $100 for working 0 hours. So that doesn't really match the real world the way that we know it. That being said, it's still how the relationship or the math question works, okay? Because you wouldn't pay for 0 hours, but you would pay for 1 hour, which would be 150, and then it would be $50 every hour after that, right? So this situation in the math still makes sense, even if it seems strange to think about paying somebody $100 for 0 hours of work. That wouldn't happen. Okay, so again, in this case, be careful using what you know about the real world too much, that you also have to look at the math. All right, let's get started here. So we know that the tiger is gaining 4 kilograms each month. Complete the following table of values for the linear relation between the mass of the tiger and the number of months since the tiger was born. So in 1 month, I'm going from 1 month to 2 months. I'm going up 1, so I'm going up 4. So it's going to go up to 18. And that means if I go down a month, because I'm going down 1 month, I go down 4. And that would take me to 10. So it turns out this tiger had a mass of 10 kilograms when it was born. Now, what happens here? I'm not going up 1. I went up 3. So I don't just go up 4 here because I haven't gone up. This is per 1 month, but I've gone up 3 months. So I go up 3 times 4. 4 kilograms per month for 3 months. Okay, whoops. And that's 12. So 18 plus 12 is 30. Okay, so this is something EQAO likes to do, is they like to change what this is going up by. So it went up by 1, then by 3. And I can't just follow a pattern of 10, 14, 18, 22, 26, 30, 34, and so on. This pattern works. This was my 0 month, 1 month, 2 months, 3 months, 4, 5, 6, and so on. Just look at what happened. It started us here. I went to there. Then I had to skip to there. And that's why I added 12, because 3 months had passed. Okay, and we also tracked back to find the 0. So this pattern of 10, 14, 18, 22, that still works, right? But I just had to be careful about skipping a few months there. State the rate of change of the initial value for this relationship. So the rate of change, it gives it to us 4 kilograms per month. So 4, and I'm going to use the units as well, kilograms per month. What is the initial value? 10. And again, I'll include units. It doesn't specifically say to, but it's a good habit, 10 kilograms. Okay, and I had to find that it wasn't given in the question. Write an equation to represent this linear relation where m is the mass of the tiger in kilograms, n is the number of months since the tiger was born. So m equals 4 times n, the number of months, plus the initial amount, which is 10. Okay, or m equals 10 plus 4n. Some people write it one way, some people write it the other. A baby lion is born on the same day as a tiger. The lion gains 0.5 kilograms less each month, but is 2 kilograms more at birth. How much more would the lion weigh after 6 months? Whoa, there's a lot of parts to this. And if you just read those two, you might say, oh my gosh, I don't even know what it's talking about. I don't know what it's asking. How am I supposed to do this? I can't answer this. Well, hold on. What have I said over and over and over again for weeks and weeks now? Always comes down to where does it start and what is the change. So let's see if we can do that. First of all, I'm going to summarize the tiger. The start was 10 and the rate or the change was 4. So now let's see if I can do the lion. The lion gains 0.5 kilograms less each month. So that's the rate because it says each. So the rate is 0.5 kilograms less than the rate of the tiger, which is 4 minus 0.5. 4 minus 0.5, which is, I don't want 7 over 2, I want 3.5. Okay, 3.5. And the start, but is 2 kilograms more at birth. So the start is going to be what the tiger started with. This means then the tiger, right? Plus 2 more, which is 12. Well, now I've got the start and the rate for the lion. So can't I come up with an equation for the lion? And the tiger, and then finally, so that wasn't too bad because I broke it down into the rate and the start. And even if you didn't know that's what you were supposed to do, and you had no idea what you were supposed to do, well, what have I always said? It always comes down to the rate and the start. So just figure those out, even if you're not sure. Try to figure those out because it gives you this information, and then maybe write the equation. And then all of a sudden it says how, like basically how much more would the lion weigh, or really what's the difference between the two after 6 months. So that means n equals 6 because that's the number of months. So for this one, it's 4 times 6 plus 10. 4 times 6 is 24, plus 10 is 34. Okay, 3.5 times 6. And I've always said this, sometimes you can do this stuff in your head, sometimes you can't. You know, if it's a decimal, maybe that makes it harder. So 3.5 times 6 gives you 21. So that equals 21 plus 12, which is 33. How much more would the lion weigh after 6 months? Well, that question doesn't make a lot of sense, does it? Because the lion weighs less after 6 months. So therefore, the lion, hold on, I'll show calculating the difference before I do this. So difference, because this is often how we've done it in the past. 34 minus 33, which is 1, but it's so easy that you almost don't have to show that, right? Therefore, the lion weighs 1 kilogram less than the tiger after 6 months. Okay, and that's a bad question. You won't see that on EQAO or on our tests. If you do see that on our tests and you're confused, you feel free to put your hand up and ask, and I'll clarify for you, because it's not meant to be a trick. That's just a mistake in this lesson for sure. But that's it. That's how you would do a question like that. Again, this is an open response question. There's a lot of steps to it. It can be overwhelming, but notice how any one of the things that we did wasn't too bad. Finding the rate was something we could do. Finding the start was something we could do. And it's comparing the lion to the tiger. You do have to recognize that. We have to figure out that we're starting with the tiger and we're figuring out what the lion is from there. But once we did that and came up with the equation, again, this part is something we've done lots of and it's not too bad. Okay, so moving forward, there will be lots of questions like this, and the practice today has a bunch of questions that are just all kinds of mixed up, different kinds of questions where maybe you're doing a table, maybe you're doing an equation, maybe you're sort of comparing two different situations, okay? But again, it always comes down to where does it start? What does it change? Come up with the equation. That sort of thing is always what we're doing with linear relations.